Simplify the rules of curtailment of reinforcing in slabs. Compiled by Mobeen Kasim, Michael Carl Jumat, Willem Johannes Swart. What is curtailment? Curtailment is a theoretical point where some of the reinforcement is cut off along the span of the beam where the bending moment reduces, given that the remaining reinforcement will be able to support the reduced bending moment. Simply, curtailment of reinforcing bars is a stopping of some of the reinforcing bars in tension or compression, where they are no longer needed for strength purposes. Curtailment can be applied to simply supported beams, but it is generally not economic, and the real advantages occur with the repetitive multi-span beams and slabs. It can also be used to facilitate construction by curtailing bars to practical lengths which are easier to handle. However, the saving in steel is offset by the increased design calculations, detailing, and site supervision.
Curtailment in slabs. When designing the reinforcement in a concrete slab, the bars that is curtailed should be fixed and anchored past the point in which it is needed to support. In order to find the point where the bar is no longer needed, the shear force and bending moment should be calculated. The procedure as follows. The method of starting to find the correct distance for curtailment is to check the actual bending moment diagram, and in order to shift this towards the direction of the reducing moment. We should call this distance A. In concrete slabs, A will be 1 multiplied by the diameter multiplied by cot of theta. Theta being the angle of the concrete support assumed in the shear design.
Rules of curtailment. Bending moment diagrams are shifted in the direction of the reducing moments by an amount equal d in cases of slabs. Bars should thus be anchored at a distance length times breadth times depth plus depth. This is the practical curtailment point or length. The curtailment of anchorage must however be greater than the effective depth of the member, greater than 12 times the size of the bar. If there is a negative moment beyond the point of inflection, 1/3 of the reinforcement provided must extend beyond the point of inflection, with the distance not less than the effective depth d, 12 times bar size, or 1/16 of the clear span of that member. The reinforcement in continuous and simple members will extend at least 1/4 and 1/3 respectively into the support to a length of 1/3 the depth of the support. If the bar continues beyond the point of inflection, the reinforcing will continue equal to the effective depth of the member, or 12 times bar size.